Hello, guys. I hope that you are doing well today. How are you all saying?
I'm good, thank you. How are you?
I'm good. We have a problem today for understanding the relation among f prime, and f double prime.
Mm-hmm.
We have a curve here, Hussein,
Mm-hmm.
and you see the blue curve.
Mm-hmm.
Given this curve, we are gonna explore the relationship between f and f prime, or f and f double prime. So we have
Okay.
a sort of some questions.
This is
Uh,
like in
uh,
XY coordinate system.
yes,
Is this like
yeah,
as a function?
yes. The blue curve is
Mm-hmm.
a function, but not f.
Oh, okay.
It is either f prime or f double prime, but we explore it very soon. So if you scroll down, please.
Mm-hmm.
In these questions, we assume that the blue curve is f prime,
Okay.
not f. It's very important point. So it's
Okay.
f prime. And
Okay.
then we have some questions. To solve this, actually to obtain the answer for these questions, you need to look at the blue curve
Mm-hmm.
with the assumption that it is f prime of x, and
Mm-hmm.
then you answer the questions.
Okay.
So do you have any questions
Uh,
regarding the problem?
no, I think it's good.
Yeah,
So let me read the first part and
yeah,
start solving and going through different
sure.
parts.
Yeah, if there are some questions I can answer, I can answer you during the solution.
Okay. Yeah. All right. So this is f prime of x,
Yeah,
not f of x. And
correct.
so the first part is asking where is f of x increasing? All right. So f of x increasing. So
You can just draw a little curve in front of that question
mhm,
with increasing a slope of f of x.
okay.
Just ignore for a second that you have f prime x up there. Just
Mhm.
draw a increasing f of x.
Yeah.
Uh,
It's just general. It's an example of increasing function.
yeah,
Um, the viewer might come up with different curve, but this is what I have in mind.
yeah,
If I have like a function like this one, I think this this branch on this side is increasing because if we draw this the tangent line has a positive slope. So this
yes.
part
And you
is,
are, yeah, you are looking at f of x in this
yeah,
curve. This curve is f of x.
this is
Yeah,
f of x, and then this branch is increasing,
yeah, that part is increasing.
and then the slope is positive. So this slope
Yes,
on this side, on the other hand, is decreasing,
correct.
and the slope is negative.
Yes,
So
and a
the
slope is f prime of x.
exactly. So positive slope means that f prime of x is positive.
Yeah,
So
it is increasing.
right. So we are actually looking into, so if this is the f prime of x, we need to find where f prime of x is positive.
Yeah, the blue curve in the question. Yeah, we concluded that okay, f prime of x should be positive based on the small sketch that you just drew.
Right.
And the blue curve, we look at the positive side of the curve.
Right.
So
So I
yeah,
think from
that's
here to
correct.
here is where the f prime of x is positive, and that means that
Correct.
the slope of the tangent line in f of x, as I drew over there at the top, is positive.
And
This curve
increasing.
here, increasing.
Correct.
So from here to here is, the interval that we have is from -1 to 2. So where x is between -1 to 2, f prime of x is positive, and as a result, f of x is increasing.
F of x is increasing, and
Right.
in that interval, minus or -1 and 2 are not included, are not part of the interval.
Right. Right.
Yeah.
All right.
So yeah, great. So that's the first question. The second question: where is f of x concave down?
Okay. Let me delete what I have here.
Yeah.
So f of x is concave down. So concave down means I have a curve like this. So
That's
this
correct.
is my f of x, and it is concave
Correct.
down, and so that means that if double prime or second derivative of x is negative.
That's correct.
So when the second derivative is negative, it means that the function is concave down. So and then we don't have the second derivative curve. We have the first derivative curve, and so if we wanted to translate that into the first derivative of x.
Yeah, actually,
So if
the
that one
blue
is
curve that
is negative, if that one is negative, means that the first derivative should be decreasing.
Yeah, yeah, or in another perspective is that, you know, you have the blue curve, and the blue curve is f prime. The slope of f prime, the slope of f prime is f double prime.
Right.
Okay.
Yeah.
And so I think on the curve you can point with laser, for example, that
so where the slope is negative.
Slope is negative, yeah.
Like this one here, or this one here.
Correct.
So here, the function, the f prime of x, is decreasing. So from here to here, we can say that
a slope is negative.
A slope is negative, meaning that if the second derivative is negative,
yes, if
and then it's concave down. So
correct.
So one interval is from here to here is from -6 to -3. The slope is negative. So I'm gonna write that down.
Yeah, please.
So x belong to -6 to -3. And then let me find out if there is another interval. So from here to here, f prime is increasing because the slope is positive.
Yes.
So that's not the interval we're looking for. We're looking for the interval that the slope is negative. And then from here to here, f prime is decreasing, meaning the slope is negative, meaning the second derivative is negative. So the second interval is from 0 to like positive infinity.
Infinity. Yeah, positive infinity.
And then I think it's union with 0 to positive infinity.
That's correct.
Okay.
Great. The third question, where does f of x have a relative maximum?
Okay, let me delete.
So again, please have a sketch, another sketch of f of x.
Okay, f of x relative maximum. So relative maximum is something like this. So this is my f of x, and this is the maximum, relative maximum. And then, so we have a positive slope on this side before reaching the maximum, and negative slope on the other side after
when you
reach the maximum.
Yes.
So on this side,
when you move from left
prime of
to the
x
right,
is negative.
from left to the right.
Sorry? What is that?
When you move from left to the right, you have positive. and then negative. So f prime of x is positive. You wrote negative. I mean.
Oh, sorry.
So
Yep. Yep.
Yeah.
Thanks for pointing that out. So f prime of x is positive before the maximum, and f prime of x is negative after the maximum. So if we look at the graph that we have, which is f prime of x.
Yeah.
Oh, and another thing is that at the maximum point, f prime of x is 0.
That's correct. Yeah.
So that means that we need to
Yeah.
look at the points that the curve of f prime of x intersecting with x-axis, which is like this point and this point. But then so this point, -1, we are moving from negative to positive, which is not the case that we're looking for. This is actually minimum, is not maximum.
Minimum, yes.
At point 2, before point 2, we are f prime of x is positive, and after point 2, f prime of x is negative. So that's why this point is a maximum.
Yes.
So let me write that down. So x equal 2 is where we have the maximum. And then so the viewer might ask, what about -6? Because at -6, f prime of x is equal to 0. But then if we look at the my sketch here, at maximum point happen where we have
change
positive,
of the sign.
Exactly, change of the sign, positive derivative on one side and then negative on the other side. But here, if we look at point -6, we have negative f prime of x is negative for the values less than -6, and also for the values greater than -6, f prime of x is also negative. So there is no change in the sign of the
decreasing.
derivative.
F of x is decreasing.
Exactly.
Decreasing. Correct. Thanks for explaining that. And then the last part, where does f of x have points of inflection?
Okay, points of inflection. Again, delete this. Points of inflection. So points of inflection is where we have change in the curvature. So we have something like this. So we have a concave down, then concave up. So this is concave down, this is concave up, and then this is point of inflection. So we are looking here at the curve of f of x. And then before the points of inflection, we have f double prime of x,
which is negative.
Which is negative.
Down, it is looking, looking
and
down
after
to
the point of
negative x.
Correct. Yeah.
Please go ahead.
And then after that point of inflection, we have f double prime of x change to positive. So that's where we need to need to look at the f prime of x and see where we have change in the sign of the second derivative. Exactly.
Since the blue curve again is f prime, the slope of that is f double prime, and you look at any interval where you have the change of the sign of the slope on the blue curve.
Right. So here we have positive slope. It changed to negative slope.
So that's one candidate.
Right. So x equal -6 is a point of inflection. So x equal -6. And then again, we have a positive slope. I'm sorry, negative slope changed to positive slope. So at x equal -3, here we have change of curvature. So
yeah,
x equal -3. And then again, we have a positive slope before x equals 0 and negative slope after that. So x equals 0 is another point of inflection.
that's correct. So yeah, you answered all the 4 questions for the curve of f prime of x. The
Oh, we
second
have a
part of
second
the
part? Mhm.
yes, we assume the blue curve is f double prime, but
Uh-huh.
since we are running out of time, we are going to have another part for this
Mhm.
video. On the
Okay.
second part of this video, we solve that actually problem. And thank you, Hussein, for solving the question. And if viewers like our video, please subscribe to our channel and hit the notification bell. And I hope that until the next video, you have a great day. Thank you very much. Thank you, Hussein.
Thank you.